We started our factoring lessons with the greatest common factor. We're going to come back to that today as we look at how to factor by grouping. Before we start grouping, let's go back and review our greatest common factor. If I look at these two terms, what are they being multiplied by the same in each term? What do they have in common? Of course it's x, and so we could say this is x. We would divide each term by x, and we're left with 7a plus 2b. Remember, factoring is just dividing, so divide each term by that. That's what I would have left. I could check that by multiplying that back out. In this next one, look, it looks almost exactly the same, but instead of an x in common, they have an x plus 7. So a greatest common factor does not necessarily have to be a monomial. A common factor can be a binomial. So they each have an x plus 7 in common. And so just like above, when I divided both by x, I'm going to divide both by x plus 7. What is left? 7a plus 2b. So just like that one had an x in common, this has an x plus 7 in common. So we're going to use this type of GCF to factor a few problems to get us ready to learn how to factor by grouping. Look at these three problems. You should see what they have in common. It's usually pretty obvious, right? On number 1, they both have an x minus 8. So we're going to write down x minus 8 multiplied by what's going to happen when I divide each of these terms by x minus 8. Here you're left with 4x, here, plus 9. That's it. That's all there is to do. On the next one, we have a 6y plus 5 and a 6y plus 5 in common. So let's write that down. And if I divide each term by 6y plus 5, what do I have left? That leaves me 3y. What does that leave me? Nothing? 0? Oh no, that goes in there one time. So that would be plus 1. So write down your GCF, divide, see what you have left. On the next one, don't get lazy. Yes, we have a 3x minus 4, but do they have other things in common? What else are they both divisible by? Well, they have an x in common. And what about 10 and 5? What are those both divisible by? 5. So the GCF, I'm just going to kind of label that. The GCF is 5x and 3x minus 4. All of that is the greatest common factor. So I can divide this by 5x and a 3x minus 4. What would that leave me? Well, 5 goes into 10 2 times, x goes into x squared x, and those would reduce to 1, so that's 2x. That divides, and just like on number 2, it doesn't leave me 0. In this case, it leaves me minus 1. Now let's say you didn't see beyond the 3x minus 4. Could we have worked that problem a different way? Yes. So I'm just going to move this answer over here and say, alright, what if you didn't see more than the 3x minus 4? You just said, hey, they have a 3x minus 4 in common. And you did what you did on number 1 and 2. Let's see what would happen. Well, we would write down the 3x minus 4, that is a common factor. We would divide. What would you have left? You would have 10x squared minus 5x. And then, hopefully, you would have recognized and said, hey, there's got to be some more factoring going on in there because I see a common factor of 5x. So maybe on the next line, you could have said, okay, let's take out a 5x out of both of those, and divided, and you're left with that answer. Well, let's pull this one back down here. And is it that different? No, in fact, it's exactly the same answer, just written in a different order. So if you don't get all of the common factor, you need to make sure you go back and you look at your answer and say, hey, can I factor further? So that is a review of greatest common factor except with factors that are binomials. So how does that lead us to factor by grouping? Well, you use factor by grouping when there are 4 or more terms. So far we've had GCF, which is for any amount of terms. We've had the difference of 2 squares, so that was with 2 terms. And then we've been looking at lots of different kinds of trinomials, which were 3 terms. So now we have 4 more terms, and we want to group them. All right? So most of the time we just try grouping them in twos. So I'm going to look at those 2 and those 2. You look at the first 2 and you say, what does each group have in common? Well, that group has an x in common. So if I divide both of those by x, what are we left with? Y plus 6. Then I look at the next group, 4y plus 24. What do they have in common? What are they both divisible by? 4. And it's a positive 4. I know that's kind of weird to put a plus, but we need to put that plus. So we divide each by 4, and we're left with y plus 6. Now is the question of, can you keep going? Do we have something that matches exactly? Yes, we do. So now we keep going and factor that as the GCF. So we're going to take out the y plus 6, and if we divide each of those by y plus 6, what are you left with? The x plus 4. So you want to group. Within each group, take out the GCF, then see, can you keep going and factor further? If we don't have something to match, then we have to regroup. Let's look at number 5. Again, I'm just going to put the first 2 and the last 2 together. Sometimes that doesn't work and we have to rearrange. So what does this first group have in common? They have a y. So if I divide both by y, that would leave me 3x plus 4. Now the second group, they're both negative, and remember how we talked about, especially if the first one was negative, you want to factor out some kind of negative? Well, here it comes. So I want to, not just a negative, but how about a negative 2? If I divide both of those by negative 2, that would leave me 3x plus 4. Not done, because factoring means everything's multiplied together. Right here I have a subtraction sign. Alright, so I'm not finished. The good news is those match exactly, so I can keep going. That's my GCF. If I divide both terms by 3x plus 4, what do I have left? Y minus 2. Now, can you check your answer? Yes, you could check it. It's not a 100% check, but again, it's a pretty good check. So if I were to FOIL it, I would get 3x times y minus 6x plus 4y minus 8. Just foiling, no like terms. And you can see I get back what I started out with, maybe not in the exact same order, but I do have all the terms that are there. Alright, so we're going to group. So the first thing, we're going to group in pairs. Let's do this. So what do these first 2 have in common? I think just a 3. So if I divide both by 3, I'm left with x squared minus 5y. What's the second group have in common? Not much, an x. Remember, if we had a negative, we're going to take out maybe a negative x. So if I divide by negative x, that's going to leave me positive 9y minus 5. Do those match? If what is in the parentheses matches exactly, then proceed. If not, regroup. Well, those don't even come close to matching. So I'm going to regroup. So instead of putting the first two and the last two together, I'm going to rewrite it in a different order. How about the first one and the third one and the second one and the last one? I kind of like that 3 and 9 and 15 and 5. Let's try that. Okay, so I'll put the first two together. They have a 3x in common. So if I divide both by 3x, that would leave me x minus 3y. Then these in common. And again, that minus is in front, so I want to take out a negative, and how about 5? So if I divide each of these by negative 5, that's going to go in there positive 3y minus x. Do those match exactly? No, but man, they're darn close, right? X minus 3y, 3y minus x, they're almost the same. This one just seems kind of backwards, right? So let's go back, regroup again. I'm going to leave the first two, but since let's see, we did this one and those two, and they seem backwards. Well, how about let's reverse the order then. Now I have a plus inside in front, so I'm going to take out a positive 5. Well, that's going to leave me x minus 3y, and now those match exactly. So when they match exactly, we can take out what matches, because that's the GCF. If I divide both of those by the x minus 3y, I'm left with 3x plus 5. I do this problem to show you that you sometimes need to regroup. You can change the order, all that stuff. Let's look at number 7. Let's just look at it. Do you think we should group the first two and the last two? That might work. But I kind of like maybe 9 and 27 going together, and I like the 12 and 4 going together. They just seem like they should go together. So let's put that in the right order. Not the right order, the order I'm talking about. So I'm going to put those together, and then since 12 is bigger than 4, I'm going to write the 27 and then the 9. I'm only doing that because I kind of see the big number, small number, so I'm going to do big number, small number. And when you rearrange, keep the signs that go with each term. Alright, so let's see. If I group those two together and those two together. So the first two, I think they're both divisible by 4x. What do you think? So 4 goes into 12 3 times, and then the x's reduce. That reduces to minus 1, not 0. Okay, in the second grouping, I have a minus first, so I'm going to take out a negative. They're both divisible by 9, and they look both like they have a y. So divide both by negative 9y. So negative 9 goes into negative 27, positive 3 times x. This is looking good. And then this divides negative 1. And sure enough, they match. Now I think the reason why they match is, 1, I got lucky, and 2, I noticed from number 6 that that second grouping was kind of backwards, and so I wanted to kind of keep the order of the numbers, big, small, and that kind of helped. Again, a little lucky. If it didn't work, I would have had to regroup. I'm not done. So they have the 3x minus 1 in common. Factor that out. Write down what they have left. There's your answer. What if you worked that problem a whole different way and regrouped it? That's fine. There's sometimes more than one right way to get to the answer. Now the answer is going to be the same. It might be in a different order, but it's going to be the same. All right, number 8. Well, I got 7s and 2s. Well, those look like okay. So this one's got a 7 and a 2. That's got a 7 and a 2. I think I'll just keep it the way it is. Well, what does the first pair have in common? X's, right? X squared. So if I reduce, that would be 7x plus 2. Well, what does the second grouping have in common? Really nothing. Okay, they always have a 1 in common. But since there's a minus, let's take out a negative 1. So if I divide each by negative 1, that's going to change the signs. And so yes, that matches. So I'm going to take out what matches. What's left? Now this one's a little tricky. Are you done yet? Can you go further? Yes, you can, because that's the difference of two squares. So I want to bring down the 7x plus 2, then factor this further. Remember the difference of two squares, where you have conjugates? That's the final answer. What if you said, hey, Mr. Nell, I didn't like grouping it like that. I wanted to put my 7s together. Well, let's do that. Let's put our 7s together and our 2s together. Now this is right. I didn't do anything wrong, but let's say you wanted to do it like this. I could put my 7s. What do they have in common? The 7 and the x. So I divide both by 7x. That's going to leave me x squared minus 1. The next two have in common a positive 2. So divide by 2. Leaves me x squared minus 1. Sure enough, those are the same. Factor that out. What do they have left? Now, isn't that the same exact thing, just in a different order? Again, I would keep going here. Same exact answer, even though I grouped it a whole different way. Easy lesson, just make sure that your parentheses match exactly before you keep going.